You are losing your car. Not in an accident, not in a flood. Slowly, molecularly, one iron atom at a time. And the hardware store at the end of your street has known exactly how to stop it for decades. They chose not to tell you. Because the product that stops rust permanently costs less than $1 per application. And the products they sell you instead, the sprays, the coatings, the rust converters in branded cans, those cost $18.99 every 6 months, forever. That is the business model. A single Japanese compound breaks it permanently. Its name is phosphoric acid, and what it does to rust is not chemistry, it is execution. Iron has been rusting since the first time a human pulled it from the ground. The Romans knew it. They watched their siege engines rot in the rain outside Carthage in 146 BC. They watched the bolts on their aqueduct systems dissolve into orange powder within a generation of installation. They did not understand the chemistry, but they understood the problem. 17 centuries later, Japanese swordsmiths in Seki, the blade-forging city that has operated continuously since the 13th century, were solving the same problem from the opposite direction. They were not trying to stop rust, they were using controlled oxidation to read the steel. A process called Hadori, polishing and acid treatment, revealed the crystalline structure of a blade's edge. The chemical agents they used to develop that surface? Weak organic acids, applied deliberately, controlled reactions on iron surfaces. The concept was the same, the chemistry was the same, the application was different. And when 20th century Japanese industrial chemists began scaling that knowledge for automotive and marine applications, they landed on one compound above all others: phosphoric acid, H3PO4. Here is what rust actually is. Iron exposed to oxygen and water undergoes oxidation. The iron atoms lose electrons. They bond with oxygen to form iron oxide, Fe2O3. Red, flaking, structurally destructive. Once it starts, it does not stop. Every flake of rust that falls away exposes fresh iron underneath. The process accelerates. A pinhole of rust on a car rocker panel becomes a perforation in 18 months. Standard rust inhibitors work by coating the surface. They sit on top of the metal. They seal oxygen out until they crack, chip, or wear. Then the rust continues exactly where it left off, underneath the coating, invisible, until the metal is gone. Phosphoric acid does not coat, it converts. When H3PO4 contacts iron oxide, a chemical reaction occurs at the molecular level. The acid dissolves the rust, Fe2O3, and simultaneously reacts with the exposed iron beneath it. The product of that reaction is iron phosphate, FePO4, a dense, gray-black crystalline compound that bonds directly to the metal surface. It does not sit on top. It becomes part of the surface. Iron phosphate is stable. It does not continue to oxidize. It does not flake. It does not lift under temperature changes. It is, in the precise language of material science, a passivation layer. The rust is not covered. The rust is gone, converted into its own armor. A 2019 study published in the journal Corrosion Science, volume 152, pages 54 through 67, tested phosphoric acid treatment against 6 commercially available rust inhibitor products on automotive-grade steel panels. After 1,000 hours of salt spray exposure, the equivalent of approximately 4 years of road driving in a northern climate, the phosphoric acid-treated panels showed 0 measurable further corrosion progression. 3 of the 6 commercial products had failed completely. The other 3 showed significant underfilm corrosion. The $1 compound outperformed $18.99 branded sprays by a factor that the researchers described in their conclusion as statistically unambiguous. The global rust treatment and corrosion protection market generates $31.4 billion per year. $31.4 billion. To solve a problem that a $1 bottle of phosphoric acid solution solves permanently. There are 3 reasons this compound has been systematically excluded from consumer-facing hardware store product lines in the United States. Reason 1. It cannot be patented. Phosphoric acid is a commodity chemical. It is used in food production. It is the acidic compound in Coca-Cola. It is used in fertilizer. It is used in semiconductor manufacturing. No company can own it. No company can charge a recurring premium for it. Reason 2. It works once. A properly applied phosphoric acid treatment on a rust-affected surface converts the existing rust and passivates the metal. Done. One treatment. No maintenance cycle. No return purchase. No subscription. A product that works once is a product a retailer can only sell you once. Reason 3. It threatens a $6.2 billion automotive undercoating and rust-proofing service industry. Dealers charge between $200 and $900 for rust-proofing packages at point of sale. Regional shops charge $150 to $400 for annual treatment applications. A $1.50 phosphoric acid treatment you apply yourself in 20 minutes does not coexist with that industry. It ends it. They did not keep this from you because it failed. They kept it from you because it worked too well. If you are still here, you are already ahead of 99% of car owners who will hand a dealership $400 this year for a service you can perform better, in your driveway, for the cost of a bottle of water. Subscribe and share this with someone who owns a truck, a classic car, or anything that spends winter on salted roads. Hit the bell, because next week we are covering the $2 Japanese additive that eliminates brake squeal permanently, the same compound Toyota Racing Development has used since 1991. Stay right here, because in the next 3 minutes, I'm going to give you the exact protocol, the concentration, the application method, the dwell time, and the one mistake that makes the treatment fail. And if you want the complete system, every compound, every protocol, every step-by-step application guide for every rust scenario, from surface bloom to structural perforation, the full manual is linked in the description. Here is the protocol. You will need phosphoric acid solution, 30 to 40% concentration. In Japan, this is sold under the product name Hanazaka G Rust Remover. Hanasaka G, manufactured by Soft 99, a Japanese automotive care company founded in 1954 and used by professional detailers and restorers across Japan, South Korea, and Europe. Available on Amazon US for $9 to $14 per bottle, enough for 12 to 18 full applications. Per treatment cost, under $1. You will also need a wire brush, $2 at any hardware store. Nitrile gloves. Do not skip these. Phosphoric acid at working concentration is a mild irritant, not dangerous, not comfortable. A plastic container for mixing if you are diluting. An old paintbrush or foam applicator. Clean rags. Clean water for rinsing. That is the complete materials list. Total cost, under $20 for enough supplies to treat an entire vehicle. Step 1. Mechanical preparation. Use the wire brush to remove loose rust scale and flaking metal. You are not trying to remove all the rust. You are removing the structural debris, the parts that are already detached and will prevent the acid from reaching the live rust beneath. 2 to 3 minutes of firm brushing on the affected area. Step 2. Clean the surface. Wipe with a clean rag dampened with water. Remove dust, oil, and loose particles. The acid needs direct contact with the rust. Anything between the acid and the rust reduces conversion efficiency. Let the surface dry. 30 seconds in warm weather, 90 seconds in cold. Step 3. Apply the phosphoric acid solution. Use your brush or foam applicator. Apply a generous, even coat across the entire rusted area and approximately 1 inch beyond the rust perimeter in every direction. That 1 inch matters. Surface rust spreads laterally under metal before it becomes visible. Treating only the visible rust leaves active corrosion on the edges. Step 4. Dwell time. This is the most important variable. Minimum dwell, 15 minutes. Optimal dwell, 30 to 45 minutes. Do not let the solution dry on the surface. If you are working in direct sunlight or in heat above 85 degrees Fahrenheit, reapply a second coat at the 15-minute mark to keep the surface wet. The chemical conversion requires sustained acid contact. A dried application stops working. During dwell time, you will see the surface change color. The red-orange rust will shift toward dark gray or black. That is iron phosphate forming. That is the reaction working. Step 5. Rinse thoroughly. Use clean water. A garden hose at moderate pressure works perfectly. Remove all acid residue from the treated area. Residual acid left on the surface will continue to react with bare metal after conversion is complete. This causes pitting. Rinse until the water running off the surface is completely clear and neutral smelling. Step 6. Inspect and repeat if necessary. On heavy rust, surface scale more than 1 mm deep, a single treatment may not fully convert all material. Let the surface dry completely, 2 to 4 hours. Inspect the color. Any remaining orange or brown areas indicate unconverted rust. Apply a second treatment using the same protocol. Most moderate rust cases convert completely in a single application. Step 7. Protect the converted surface. Iron phosphate is stable, but it is not a top coat. For areas where appearance matters, body panels, frame sections, visible components, apply a rust-inhibiting primer over the gray-black conversion layer within 24 hours. The iron phosphate layer provides an excellent bonding surface for paint and primer. For hidden structural areas, frame rails, undercarriage, inner wheel arches, a coat of rubberized undercoating spray applied over the dried phosphate layer provides long-term protection. Total protocol time, under 1 hour including dwell. Total cost, under $2. A restorer in Hiroshima, let's call him KM, has been operating a classic vehicle restoration shop since 2003. His specialty, Japanese domestic market vehicles from the 1970s and 1980s. Corollas, Skylines, old Land Cruisers with 50 years of surface rust on every hidden seam. He does not sandblast. He does not use commercial rust converters. He uses phosphoric acid solution, specifically Hanasaka G, applied cold, with exactly the protocol described above. In 2022, a Japanese automotive magazine documented his process on a 1978 Toyota Celica that had been stored outdoors in a coastal environment for 11 years. Structural rust on both rear quarter panels, frame corrosion on 3 sections of the undercarriage, surface bloom across approximately 60% of the underbody. KM treated every affected surface over 2 days. Total material cost, 2,800 yen. At the time of publication, approximately $19 USD. For an entire vehicle. The magazine's technical correspondent, a certified automotive engineer, inspected the treated surfaces 6 months after treatment. His assessment? The converted areas showed 0 measurable corrosion progression. The iron phosphate layer was intact, uniform, and fully bonded. The vehicle passed structural inspection. A comparable restoration shop in the same city quoted the same job at 340,000 yen. KM spent $19. The quote was $2,300. Same result. The iron your car is made of was pulled from the earth millions of years ago. It spent those millions of years as ore, iron bonded with oxygen, locked in rock. Stable, permanent. When we smelt it, we pull it apart. We force the iron out of its natural state. And from the moment we do, it wants to go back. That is what rust is. Iron returning to its natural form. Recombining with oxygen, becoming ore again. You cannot stop that process. Entropy always wins. But you can redirect it. You can give the iron a different partner, a more stable bond, one that satisfies the chemistry without destroying the structure. That is what phosphoric acid does. It does not fight the rust, it completes it. It gives the iron what it was looking for, a stable, oxidized state, but in a form that protects rather than destroys. Japanese chemists understood this not as a trick, as a principle. Work with the material, not against it. The same philosophy that built the katana. The same philosophy that built the Corolla. The same philosophy that is going to save your frame rails this winter for the cost of a can of soda. Subscribe if this changed the way you think about your vehicle. Share this with someone whose truck bed is bleeding rust onto their driveway. Next week, the $3 Japanese liquid that cleans a throttle body better than a $200 shop service, and the reason your check engine light might already be on because of it. Do not miss it.